In this video, we're going to solve for a coefficient of static friction. So we're told that a large block is placed on a plank. One end of the plank is then raised to form an incline. The block remains at rest but is just about to slide. The block experiences forces of 42 newtons perpendicular to the incline and 26 newtons parallel. What is the coefficient of static friction such that the box stays at rest? So we're starting with just a horizontal plank or a board, and someone puts a block on top of it, and then we're going to raise the board on one end and create this incline. So now we have the box that's resting still on the board, but now it's at some incline, so it has some angle. And we're told that the box is at rest, but it's just about to slide. So if you would raise it any more, then the box would start to slide down the incline. So we're told that the box experiences forces of 42 newtons perpendicular to the incline. Okay, so how would I represent that? So we want to stay perpendicular to this incline. So the box is going to experience a normal force that is perpendicular to the incline. This normal force is not perpendicular to the horizontal, it's perpendicular to the incline. And we're told then that it also experiences a 26 Newton force parallel to the incline. So that could be pointing in either direction, but what I'm thinking of here, and there's actually two ways to write this. So the first that I'm thinking of is, okay, there must be some friction that is holding this box on this incline plane, but then we also know that there is something that's pulling it downwards, because if you would raise the box just a little bit more, then it would start to go down the incline plane. And we know also we can then make the conclusion that if we have this normal force pointing upwards, well, there is a force of gravity, but which way does it point? And we have to remember here when we deal with planes that the force of gravity always points straight down towards the center of the Earth. So it's going to point straight down this way. So this force of gravity, W, is not equal to the magnitude of this normal force. And I don't even need to label these forces to solve this problem. This is just something I do out of habit. So we have a force of static friction. And this would be a component of the force of gravity that is pulling it down the hill. So I'm just going to put an F here. So we're asked then, what is the coefficient of static friction such that the box stays at rest? Okay, well, I have to think back to the formula for static friction. I know it's F sub S is equal to mu sub S. This is the coefficient of static friction times the normal force. And we're wanting to find this coefficient of static friction such that this thing doesn't move. And we're already at that point where we're just on the verge of this box starting to slide. So we're there at the maximum of this force of static friction. Remember, this is both an inequality, so it's either less than or equal to this value. The force of static friction can be less than this. We're at the maximum point. We're at the point where this force of static friction is going to be equal to mu sub s times n, because if we tilt it any further and this force vector gets any larger pulling downwards, then it's going to start to slide. That's the breakover point. But we're at the point where F sub s is equal to mu sub s times n. It can be less than or it can be equal to. If it's equal to, this is the maximum of F sub s. So this is the formula that we're going to use. And we need it to be an equality because we wouldn't really be able to solve for the case where F sub s is less than mu sub s. We need an equation. We need equality to be able to say, okay, yes, the value of the coefficient of friction is something, which we're about to find. So what do I do then if I want to find the coefficient of static friction? Well, then I divide both sides by the normal force. And I see then that the coefficient of static friction is equal to F sub S divided by the normal force. And these are just the magnitudes of two forces. And what does that look like? Do we have that information? Well, we're told that the perpendicular component is 42 newtons. Well, what is the perpendicular component up here? The perpendicular component is the normal force. We don't even care about the weight force in this problem because we're told, hey, the perpendicular component is 42 newtons. Well, that's the normal force. So the normal force, from what we're told, is 42 newtons. And we're told that the parallel force is 26 newtons. Well, the parallel force is this. This is one of the parallel forces, which is good. That's what we need to solve for the coefficient of friction. So the magnitude of F sub S is equal to 26 newtons. And now I have everything I need to solve for the coefficient of friction. So I'm just plugging in the values of the normal force and the force of static friction. And we can see that mu sub S is equal to, again, the force of static friction divided by the normal force. And then plugging in these values, it is 26 newtons divided by 42 newtons. And like I mentioned previously, the coefficient of static friction does not have any units. And when you divide newtons by newtons, you get 1. So there are no units in this value. This is a scalar quantity. So this number tells us the ratio between the force of static friction and the normal force. How much, this is saying how much static friction do we need per normal force? And this number then, if we just take 26 divided by 42, obviously it's less than 1. And to 2 decimal places, it's going to be 0.62. And that's it. It's a scalar. There are no units. And what does this number tell us? This number kind of like sitting by itself seems kind of meaningless. Well, this is going to be a characteristic of this actual surface. This surface, whether this is like a wooden board or maybe the plank is made out of plastic, whatever, it's going to have some sort of characteristic that's different from something else. Say if this were a board covered in a layer of carpet or something like that. This number just tells you how much force of static friction do you need per normal force before this thing starts to move. Remember, if this plane starts tilting anymore, it's going to start to move. So this number is the maximum force of static friction, and it's tied to this coefficient of static friction, which is a property which tells us properties of this surface.